look here now is at the ventilated facade systems. We're going to talk a little bit about what happens behind it and behind the panel. So we have this thing about ventilation and thermal and blah 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 blah. So we all understand that between residential and commercial there's generally different buildings, different rules, different things to do. So one thing that came up here the other day in training is that once you get into high-rise buildings or higher-rise buildings, does anybody here know what the limit is for where the fire rules change?
3 floors, 9 meters.
9 meters. So below 9 meters you're pretty okay, but above 9 meters what changes? The fire resistance of the wall, of the on the material?
The building usage.
Yeah. And does it mean then that they have to like upgrade the materials? Because you remember what, did everybody see what happened in Dubai on them hotels and stuff and them apartment blocks?
Create fire breaks every 3 meters after.
Right. And what about the material that can be used above 9 meters? Do you have any restrictions or the fixing systems? So roughly 9 to 10 meters high, and then you have to change your rules. Okay, that's actually quite tight here. In most countries it's around the 16 to 18 meter mark. Usually relates to the height of the fireman's ladder.
So a lot depends on the building type.
Yeah.
Well.
Okay, okay. Bear that in mind if you're doing this. Yeah? That all of a sudden, you asked about glue. Glue may not be acceptable over 9 meters here. You may go ask your fire officers. Because you may have to have a certain rating on the fixing system. And the glue can only get you to a certain rating. Rivets will get you to another rating. It's also important with the panels. You probably need a panel that has a very good spread of fire resistance. And some of the other materials you could use, like in these tower blocks that went on fire, they use cheap materials, and like the whole tower block went up in 15 minutes, the whole wall.
Polyester on the you know, these composite panels, it's polyester that jam between them, but they've changed all of that now to fireproof material.
No. You mean the ACMs, the aluminium? Yeah.
Oh
Yeah. No. They haven't changed it. They've brought you out new ones with fire that you pay a hell of a lot extra for. You can still buy the bog standard D-rated fire ones as well, because they normally would be all right at lower level. But like you say, they do have the higher ones. But what was happening is the higher ones were being specified, but the non-fire rated ones ended up being used on the jobs. And there's huge problems in other cities in the world on that as well. If you are interested in it, and just to keep your head, like, go YouTube or Google what happened in Dubai, and particularly what's happening in Melbourne, Australia at the moment. Last reports is that there's 60 apartment blocks, tower blocks in Melbourne that need replacing in the next 2 years, that have only been built in the last 4 years. They're only 4 years old, the oldest of them, and they have to start stripping the material off of them and replacing it with better fire performance materials. Woohoo! Long may it last. Okay, residential and against commercial, there is some kind of different rules, just be wary of them. Solid masonry, lightweight frame. There is differences when it comes to you guys if you have to design up anything. A masonry wall by far for putting your frame on is probably the easiest one, because you can get your anchors wherever you want. When you're on the lightweight gauge steel frame, you're normally in, if you're lucky, at 600 centres maybe, but them 600 centres are not going to match with the 600 centres on the panels, unless you're absolute geniuses in building it all up. And don't forget, you guys probably won't do, I don't know if you do or not, but most installers don't do the gauge system. That's usually there, and then you come, maybe somebody else might come and put the frame on, and then you put the panels on. And trying to get all them coordinated through is virtually impossible. So when you come to a lightweight steel gauge system, you've got to have some kind of horizontal noggins, strappings, horizontal frame system in first. So that means then you can put your verticals in any position, and it doesn't have to match back in with the studs behind. You know what I mean? Sorry there. No. So if you have your lightweight gauge steel section here, you're going to have a sheeting board on the outside, and our panel is going to be here somewhere, and the architect wants to have a rivet in here, which means if we have an L rail here, you want to put your rail there, you've got nothing to fix into from behind. Because the chances of this point here lining through with this point here, I would give you a 0.001% chance of any one of them probably hitting each other during the construction. So this is to get some structure in here. You know, you're either going to have to have some noggin pieces in here. In America, they use metal band straps across the face, or you're going to have to introduce maybe a vertical section would be, this is your stud, this is your wall. You may put in a couple of simple top hats fixed into these, running horizontally, and then you can run a simple top hat system down on top of that. And that little space in there is an invitation for extra insulation to be used for the architect. Okay? So just bear that in mind with the LGSFs, right? You may change from this angle bracket system maybe into a top hat system. Might be more economical, easier to use as well. That's what's happening in the States. You're aware of, do you guys do these render on insulation systems on the outside? Yeah? Any problems in South Africa yet on them?
Yeah.
What's happening?
Polystyrene's
It's what?
well, they've actually to get the joints sorted out because the polystyrene has variations of stiffness.
Yeah, well actually what you're supposed to do is once you've put that on the wall, you're supposed to go over and sand it all down. And clean it all down and sand it all down with these machines to make sure everything is nice and level. Don't do that, no? There's a bigger problem. Basically, one of the differences between that and what we're going to discuss here is that on these systems, they're trying to keep everything on the outside of the wall. And that the render becomes the complete water barrier. It becomes everything in this little thin material that's on it. So you have all these other materials in behind it. You have masonry, you have polystyrene, you have the meshes and everything are all moving and stuff. The biggest issues they have is where they have finishes around doors, around windows, around balconies. If you want to see what's happened to the housing industry in New Zealand and in Vancouver in Canada, go Google it with these systems, particularly on light gauge steel frame systems which move like crazy. The render systems can't handle it. So in a lot of places in the world now, they're introducing cavities into the construction behind the renders. So when the render cracks, the water can at least escape. Okay? And then when you get up into the more commercial areas, of course, you're into the curtain wall systems, stick. You guys do curtain walls? Glazing walls, glass walls and stuff, yeah? What, the stick systems or the bigger panel systems? Yeah? Cheap, aren't they? Miranda, take note of this. Much per square meter, approximately? For a stick system. What, with a 16.6, well, sorry, was it a 610.6 glass system? In Europe, it's about 400 to 600 euros a square meter for the frame and the glass. Yeah? That's many, many, many times the price of our system, even if you were putting a framing system in on it. So when architects are willing to pay that for that, they're willing to pay a little bit for ours as well. Anyway. And then we have our ventilated facade, which we're going to talk about. And in simple terms, a ventilated facade is a two-stage construction. The skin, which is our panel on the outside, protects the structure. It doesn't give it 100% protection. It might give it 80%, 90%, depending on the climate. And the general build-up of the wall is an outer skin of panels. Do you guys call it range screen or ventilated facade? Yeah, I call it range screen because it's easier for me then, if you understand the difference. It's funny, English-speaking world, or those more familiar with English, call it this. And non-English speakers, my buddy from France here, will call it this. There's always an air gap or a cavity space behind the panels, and then normally an insulated backing wall that controls air leakage as well. That's generally the build-up. It's a much valued form of construction now for the architects. It's growing in popularity the world over. Even on us, we're only one of the players in the market. The increase in volume has been tremendous over the last few years. But this form of construction brings many benefits to the building. Now, when it comes to our panels, you asked about our panels and ventilation. Yeah, we'll talk about the ventilation for what it does for the building, but our panels are balanced for the ventilation in the cavity space. So, what's on the back of our panels and what's on the front of our panels is designed for ventilated scenarios, okay? Panels are a perfect complement to this construction type. Don't even know why I wrote that in. How are you guys finding it, trying to talk about ventilated facades, range screen systems? Do you find the industry is all up together with it? Do everybody understands it?
Yeah, not everybody. I think the new energy efficiency trade in South Africa is creating a draw towards architects researching that a lot more.
Yeah.
Because they need to create energy efficient buildings,
Yeah.
The outer shell.
Yeah.
So I think that's certainly getting momentum now.
Right. Do you find, guys, that there's a generation thing with the architects on this? That maybe talking to a younger architect may be more up on this type of construction, because it is relatively new.
I don't think it's hit the South African curriculum at engineering level or building level. So
Okay.
It doesn't, usually if it goes into curriculum, post graduates will use it. Right now it's not in the curriculum.
Marinda?
Only the architects will go through CPD points, routine
Yeah.
and that's the only time to really get it up and go.
Yeah. Make a note of that there for yourself. Yeah. You may have to do something on the architects industry. Yeah, you're right. It's a growing thing. Those of us that are more developed, we still do CPDs in most countries to try and educate the architects every year and every time we can, just on this type of construction. Right, just from your knowledge and what you know about it, or whatever stories you've heard, like what benefits do you think it might bring to the building? First question, what do you think? Now guys, I'm getting very little comment from the back row there. I won't bite your heads off if you do speak, by the way, okay? What do you think that Equitone brings to the party here on this ventilated facade? Does everybody down the back understand what ventilated facades are?
Yes.
Yeah? Okay. So, what do you think Equitone brings to this? Because I'm sorry I'm picking on you, because to be fair to you, you're top man asking most of the questions. But that's an Irish saying, by the way, top man. What we're saying here is that, you asked the question about, Equitone and our systems and ventilated systems and all the rest of it. What do you think would Equitone bring to the party?
A tough facade.
Hmm?
A
Tough facade, yeah?
Aesthetics.
I'm not very good at spelling, so I'll put looks. Okay? Basically, guys, that's what it brings to the party, okay? On a ventilated facade system. What we're really doing here is a pre-finished board is giving the architect the look he wants on the building. So when we're coming into what the benefits of using this on the building would be, it's more to do with the construction that happens behind the panel. We insulate on the outside of the wall normally. I believe your insulation regulations have just been come to the fore and have been in. Do you work on U values, by the way?
R values.
R values. Sure. That's the inverse of U. So what's your R value then normally?
Right now?
Yeah.
Masonry work?
Yeah.
0.26, 0.13. And then the requirement for alternative building technologies 2.
0.2.
2.
2.
Yeah. Should be. That's what they're driving it towards.
So the inverse of 2 then is you're looking maybe around 1 kilowatt. The U value. All right, I'll work it out myself. I need a calculator. Okay. Well, you're on R values. Okay. Like USA. We work on U values, which is the inverse of that. But 2 is quite high. Basically, from memory, 2 is what we were probably 15 years ago. And what I will say to you is there's only one direction that figure is going to go. Yeah? Up. As you go up, I come down. And basically, that's going to go up to 2.2, 2.4, 2.3, until you come to something like... So what would give you on a masonry wall, what gives you your 2? 50 mil of insulation?
Well, they'll use EPS in the cavity of the wall.
Yeah, what
You
thickness?
still won't get it. I mean, if your cavity is 40 millimeters, you'll only get an extra 1. So
Yeah.
they're 1.26.
Yeah,
If it's a cavity wall,
right.
which is still
What's that, 40 mil?
40 millimeters. Yeah.
Okay, so you're probably going to have to go to 60 or 70 mil to get your 2. Right, in Scandinavia at the moment they're on 200 and something millimeters of insulation in the wall.
So right now there's like a moratorium on brickwork in South Africa,
Yeah,
but they're driving towards 2.
yeah,
So
okay.
it's 2 or 4.
All right, I'm just warning you going forward, that is just going to change. And for ventilated facades, I've seen a number of jobs I've been visiting lately here when I'm being, because it took so long to get me here. I'm afraid my colleagues are really using and abusing me in a nice way, I must say, not in a bad way. And we've been looking at a few jobs, and I haven't seen a hell of a lot of insulation used over the last number of years, but it will come. And with ventilated facade, it's an ideal opportunity for the architects to introduce insulation onto the wall and the structure. So, if you imagine we had, actually we answered that question already. If you imagine then we had your masonry wall and we had our insulation here, and we have our panel out here somewhere like this, and this is a ventilated cavity space, right? What benefits to the building do you think that construction has?
Flush out condensation.
Flush out condensation. Actually,
Very
good way of saying that. I like it, I like it.
keep the system dry.
Yeah. We normally say controls condensation,
Yeah.
right? What else? Insulation. What does insulation do?
Supporting tool. Thermal performance.
Yeah. That's a great way. Like that's unusual for me to hear, keeping the building cool first, because I come from a cold climate. So for me, it's normally keeping the building warm. Yeah. But you're right. Keeps the building cool, can reduce your AC consumption dramatically. We bought a car a number of years ago. AC was an option. I don't know if AC is always on your cars here, is it? Yeah? Yeah, you have to. Yeah, where I'm from, AC is an option. So we asked your guy how much was AC. He said another 1,500 euros. He said, but there is an alternative that costs nothing. He says it's called the 50-50 method. 50% of the windows open at 50 miles an hour, keeps you cool. All right. Hence, I didn't buy the AC. We don't need it. For us, but I'll let you know, for us, 22 to 24 is a warm summer. Yeah? Come on, what else then? Keeps the building cool, keep the building warm, controls condensation. You basically have the majority of them here at the moment. There's one other one, which is quite important for engineers and for architects.
Could be a fire barrier.
All right, we leave that down here for a minute, okay?
What about maintenance?
Maintenance, yeah, but we're mainly, in what way do you mean maintenance?
There's maintenance
On this or back here?
on the facade itself.
Okay, on the facade. Yeah, that's more to do with the panel though.
And acoustical performance.
A what?
Acoustical performance.
Yeah, depending on the insulation, yeah, acoustical, okay, sound. Sorry, no good at spelling, sound. Okay, there's one other thing, quite important. What happens to all building materials when the temperature changes? Thermal movement, expansion. Why do you put in control joints? Why do you put in movement joints in the building? Right? Thermal expansion of the building. Right? By having the insulation on the outside, the structure of the building is kept at a constant temperature. So, if you get your temperatures here, which I can believe could be, you know, if you're very unlucky in the winter time, you might get to -3, 4 or 5 or something, maybe, certain parts of South Africa. And then in the summertime, if you're lucky, or lucky in your case, you might go to 40, 41, 42. Like that's nearly 50 degrees change in temperature there. If your external structure is exposed to them kinds of changes in temperature, let's be honest, what's going to happen is everything's going to start moving. And because in modern construction we use different materials in combination with each other, things start moving at different rates and expanding at different rates and everything like that. So by keeping the insulation on the outside, what happens is that part of the building there will always remain in around the 20 degrees, which is the comfortable degrees for the occupants. Whether it's in the winter time and you have the heat on, or whether it's in the summertime and you have the AC on. So the thermal expansion of the building. You guys in the curtain wall, you always have to design around where you have your concrete floors, a certain amount of drop in the concrete and all of this kind of stuff, yeah? There's a lot less of all that. That's usually under self-weight, but the expansion and the contraction allowances you normally have to make where the insulation is on the outside compared to a standard glass wall could be a lot less, because the building is, the main structure of the building is kept at a constant temperature. One of the biggest arguments for having a ventilated facade is that's one of the real benefits it brings. But the secret is, for most of the benefits, it's placing the insulation on the outer face of the wall. So we'll now talk about what happens if you're on a refurb project. So you say you're having an apartment block, 30 years old. They want to up it and maybe charge the people twice the rent next year. And they want to change the outside look of the building as well. Or somebody doing a house and a refurbishment, moved into the house, want to modernise it, give it a contemporary look. You have three places generally for putting the insulation. On the internal of the building, in the middle where the cavity wall is, if you have a cavity wall, or on the outside of the building. I'm going to give you the answer because you're going to go through all three stages since you're new into the insulation. People are going to promote putting it on the inside. Cover your ears for a moment, please. Cover your ears.
Yeah.
And it's usually the plasterboard guys that have insulation stuck on the back of it. Yeah? By the way, my colleague, he's a specialist on plasterboard, so there's a little bit of banter between the two of us. But to do that, you now got to change your radiators, usually on the outside wall. You've got to change your wiring. You've got to change your decoration. You've got to change your floor coverings. It's going to affect your ceilings. And the people will probably have to move out of the house. Insulating on the outside means everything is done externally. And the only really thing you have to extra concern yourself about is the windowsills, to make sure they're changed to make them big enough. You know? So, getting back to this benefit. Summer has a cooling effect. Structural movement of the building is minimized. Acoustics. Thermal bridges. People understand what thermal bridges are? Thermal bridges. Down the back. Basically, on a thermal bridge, it's normally where the floor meets the wall. This is your normal construction for the wall here, like this. And what happens is, on a thermal bridge, is that the heat will normally get, okay, we'll imagine you're in winter time because it's easier for me to explain. The heat will normally travel from inside to out. And as it travels from inside to out, it cools down. And the cold air can come back in this way and make it cold. And then there's a risk of getting condensation in this area and this area here. If you insulate on the inside of the building, you insulate here and here, but you still have this bridge spanning across. However, if you insulate on the outside, here, all of this area here is now kept nice and warm and at a constant temperature, and the risk of condensation are dramatically reduced. Okay? Now, we will be coming back to thermal bridges a little bit later on, but in simple terms, what it means is it's a bridge between the inside and the outside where heat or cold can travel. Okay? And metal is usually the biggest, fastest carrier of that. Very efficient in controlling condensation as well. What happens is if you have a breathable construction, does everybody understand condensation and dew point and stuff like that? I know you guys do, yeah. Down the back. I'm going to pick on you all day until you start answering me. Right. What can happen is in the constructions, solid wall constructions, as I won't even say inside or outside, as heat is traveling through the wall, usually the wall is cooler, there comes a point somewhere called the dew point where water vapor, which is condensation, which is what I'm breathing out here now, when your windows go wet on the inside or whatever, that water vapor, There's a time when that changes from water vapor to water molecules like liquid. And that's generally called the dew point. And that happens at a certain temperature. So you have warm air coming out, you have cold air coming in. When it hits a certain temperature, it now turns back into water. That's where condensation becomes detrimental and becomes a problem for the building. And you can end up with having all sorts of problems. You could end up having mold growth. In worst case scenario, then it can start breaking down the structure of the wall as well. Now that's an extreme case. And basically what it ends up developing is into a very unhealthy building for people. Yeah? So, by us insulating here on this side here, what generally happens is that the dew point gets pushed out normally to there, because everything between there and there is all at a high enough temperature to stop it happening. And if the force is fast enough, it gets into the cavity space and gets whipped up the cavity and just gets thrown away. Another huge advantage. Okay, I'm spending a bit more time. What happened in Canada and New Zealand, like I said earlier, and all of that is complicated to understand. So they came up with this simple 4 Ds of weather tightness. How to keep your house nice and dry and healthy and everything, and they gave it 4 Ds. Deflection, which is basically about design. Type of eaves, the type of cladding you use. Yeah? That's where we step in. Drying of the construction. Ventilation. That's where the cavity comes in. D2, drainage of water. Any water that gets past the outside of the wall can be safely drained away as a secondary line of defense. That's where the cavity of ventilated facade comes in. And 4th, where we come in and win hands up, is D4, durable materials for all conditions. Yeah? So, it's a very simple, easy way of... Well, hey, hold on guys, excuse me, I'll just have a sit down for a minute. We have a question from the back row.
If you have a cavity and you put the insulation on the outside, the panels is standing away from the wall. Can I close it at the top and close it at the bottom, or will that defeat the purpose?
If you put insulation on the wall and you close my cavity behind the panels at the top and at the bottom, you're defeating the purpose.
Okay.
Yeah, because what you're going to have there is you're going to have stagnant air.
Air inside there.
Yeah, where what you want is you want a movement of air.
Yes.
Right? If you have stagnant air, it then starts becoming more like an insulator and stuff, and it warms up and it heats up, and then you're introducing heat, so you're losing the cooling effect in the summertime.
And if it's just a normal facade and I want to close at the top of the bottom, no insulation, can I do that with your panel?
No, I prefer to have ventilation. As I said, our panels are designed for ventilation. Yeah?